Well, thank you all for coming to this talk. This talk is basically called Hadoop, the Foundation of Healthcare Analytics. And my name is David Haubenstricker. You can probably guess that I trace my origins back to Germany through Frankenmuth. Most people would just call me David because it's a little bit easier to handle. I'm the enterprise architect for Truven Health, and I'm doing that in part because it's penance, because I spent 16 years working for a large pizza company, developing things like their point of sale system and their e-commerce system, and so I figured that since I had been on one side of the tracks, it probably was time for me to get to the other side of the tracks. Okay, what this talk is basically going to be about is how our company, Truven Health Analytics, has adopted Hadoop. And so what I'm going to be doing is talking a lot about the key decisions we made, how we went about doing it. This is primarily going to be in the form of a case study or a story. So you get out of it what you feel like, but hopefully we'll enjoy the process. Who is Truven Health Analytics? You can read the slide, but we've been around for a while. We've had various different names. We were probably first started as MedStat, and we've grown over time. About 2 years ago, we became our own company. We're bought by a capital investment firm, and so we're sort of standing on our own now. The core of our business is that we work with insurance companies and other what we call payers, people who pay for healthcare, and we provide them with analytic solutions. So we basically take in their data and we serve it back to them. We also work with healthcare companies, providers, so like hospitals, to help them analyze their data. And then we have a little bit of additional business, which is really related around drug interaction information and drug data. So this is the core of what we do. So why Hadoop? Or let me give you, this will be 2 slides that will basically sort of cover what you need to know about Hadoop to sort of get something out of this talk. You've probably heard all this about big data. It's really about volume, it's about velocity, it's about variety. The volume basically means you have so much data that your relational database just can't seem to hold it. The velocity is either you're trying to get data into the system so fast that the system gets clogged up and it's 24 hours a day to get 24 hours of data into it, or it's getting the data out. It just takes so much processing to get the data out. And the variety has to do with the fact that we're getting so many different data sources now. And there's talk about documents and video files and images and other such things coming in, and Hadoop seems to be a real good place to process that data. So really, Hadoop has almost become synonymous in the industry with big data. And so if you say you're doing big data, and then if you say you're not doing Hadoop, people will generally be scratching their heads. So what is Hadoop? So there's 2 things I want you to get out of an understanding of what Hadoop is. One is it's really nothing more than a massive distributed file system. So I have my Hadoop cluster here, which has a whole bunch of computers in it. And if I want to add more computers, I just wire them in and boom, my cluster grows. So I have lots of computers, and then I have a file. And now, when I have a file like this, what happens is it gets broken up into pieces and it gets distributed across this entire cluster. So that way, if you need to grow, it's not about getting bigger machines. It's just a matter of plugging more machines into the cluster, yet it presents this view where everything looks like it's one. Second big thing about Hadoop is its distributed processing. So I have a program. In a normal relational database, what happens is I write a program, and it generally has a SQL query in it, and it goes out and fetches the data, and it sucks it back into the program, and the program processes it. Well, in Hadoop, that changes. It takes that program, and it basically copies it, makes many copies of it, and it sends all those copies out to the different nodes in the cluster. So what's happening is, rather than having all that data go back to one node, where the program's running, the program gets copied to all the nodes, and we have a certain scalability now in terms of being able to process data. So obviously, each of these programs is now dealing with 1/12 of the data. Now, this obviously works well for some algorithms and not well for others. And that's part of the learning process, that as you sort of adapt to Hadoop is figuring out which algorithms are which. Here is a very simplified diagram of how my company works. And because I'm the enterprise architect, I need it simple and high level so that way I can talk to executives. Okay, so I have up here, I have hospitals, I have insurance companies. What happens is they basically send me data. Oftentimes this data is claims data, or it is billing data, or sometimes it's actually directly out of the hospital system. And so in which case it's almost a real-time feed. So we take that data and we need to cleanse it and transform it and prepare it for our applications. And so that's what we do here, and then we basically drop it into a big data warehouse. Probably very similar to what you do in many of your companies. Then what we do is, out of that data warehouse, we support many different applications. We've got like over 60 different applications that our company offers. So what we'll do is we'll write a builder program or something that's extracting the data out of the data warehouse, and we're building a focused data mart for that particular application, often for that particular customer. So we will very likely build a database for each customer for each application that we're dealing with. And then finally, the customer is then going to be interacting with the application, which is going to generate queries against that data mart. Very simple process, sort of basic business intelligence 101. So, we started assessing our environment. As Hadoop came around, everybody was going, wow, Hadoop, the silver bullet. What can we shoot at? What can we shoot it at? And so there was this real desire to bring Hadoop into the company, in part because we're an analytics company, because Hadoop equals big data. It seemed like we ought to have Hadoop somewhere in the company. So what we did was we started analyzing where our pain points were. So we looked at our transform and load process, and we basically realized that this is primarily a labor-intensive problem. So our problem is that as soon as you sign up, we have to go through your data, figure out what you're sending us, what it looks like. We have to apply our cleansing routines, our standardization routines, et cetera, et cetera, et cetera. So you may say male is 1, female is 0. Our system, we may want to store it as male is M, female is F. And so we need to do all that kind of standardization. So it's a very labor-intensive process. Next, in our data warehouse, our biggest problem with our data warehouse was money. So we have a huge Oracle cluster with incredible numbers of CPUs and stuff that are running on that. It's sitting on top of a SAN, very expensive storage. And whenever we start running out of space, we're looking at either upgrading the machine, potentially clustering machines. It's a nightmare of expense. In terms of pain points for our builders, when we're extracting that data out, it's mainly a time problem. So we're pulling the data out of the system, we're summarizing it, we're transforming it, preparing it for our data mart, but it's taking too long. Finally, in our applications, there's also a time problem, but it's mostly a time problem of the response time of my application. So everybody wants their web pages to come up like that. Business intelligence systems seem to have a favorite icon, which is a hourglass or spinning beach ball or whatever have you. And so that's one of the issues that we have, is that it's a business intelligence application. And frankly, we have an additional problem that for most of our numbers, they don't aggregate well. Because what we're often doing is we're counting patients. And so you may show up in January, and you may show up again in March. And if I summarize those and say, okay, in January I saw 1 patient, and in March I saw 1 patient, but then if I aggregate across the year, it's not 2, but it's still 1. And so that's one of the things that makes it especially difficult for us, and one of the things that results in that hourglass. So then we started to apply Hadoop to these problems. So we first applied Hadoop to this problem, and we basically said, it isn't going to help us. It's a labor problem. Hadoop doesn't help with the labor problem. So what instead, we then looked at the data warehouse. Will Hadoop help us here? And the answer was a definite yes. Hadoop, because it uses many commodity servers that are running local storage, just regular hard drives, results in a storage solution that's much, much cheaper than sitting out on a SAN or doing other sort of more expensive solutions. In terms of our builders, we felt that this was also an area where we could get some improvements. Again, because you saw how the programs divided up and went across the whole cluster, we literally could grow in terms of the amount of horsepower that we could apply to our problems. So it was a very good fit here. And finally, we looked at it at our application level, and it was not a fit here because Hadoop is primarily, at this time, a batch-oriented system. And so your minimum response time for most activities is usually around 20 to 30 seconds. And so it wasn't going to be a good fit here. So we took this and we said, okay, then what does our target look like? What does our future look like? And what we said was, okay, it looks like the future for us ought to have Hadoop, focus on Hadoop covering those two areas. That enterprise data warehouse, that sort of extraction building process. And I'll talk a little bit more about what that reorg is a little bit later in the slides, but we found that there's some additional optimizations that we could make. So this ended up being our target, Hadoop, Hadoop to do really back-end stuff. It was our big muscular man that could grow easily and have that scalability. So with that, as we sort of talked about it, we expected, some of our expected benefits were obviously lower cost, better performance, a more scalable system, and it gave us a little bit more cred when we said we were a big data company. Well, Oracle will say you're a big data company if you just have Oracle in-house. So here was our plan. Once we had sort of realized that Hadoop was going to be a fit for the company and where it fit, we said, hey, let's go through, and here was our plan for rolling it out to the company. So we obviously needed to do a proof of concept. Let's try to prove what we thought was true about this from a theoretical whiteboard point of view. We knew we needed to select a distribution of Hadoop. There's a few different major ones out there. We wanted to start with a single project. And so pick a project that would basically spearhead this process, and then finally there'd be a more general rollout. So our proof of concept was very simple. The idea was to get the developers, set up a little test cluster, get the developers out there, get them using it, hands-on. Hadoop is really an ecosystem of tools, as you've probably learned, that even though the two core components that we talked about earlier, that distributed file system and distributed processing, there are a ton of tools that sit on top of Hadoop. And so this was an opportunity for the developers to really kind of get a chance to play around with those tools and figure out which ones work well and which ones don't work well. It was a time for our operations team to really kind of understand how to administer Hadoop. And so they had to install it, upgrade it, start to manage it, and get their hands on it. We do a cost-benefit analysis, and then finally we'd have some scenarios where we could kind of do comparisons. Okay, here's Hadoop versus our existing solutions. So what happened? Well, the developers actually learned something from the POC. They learned that you don't think relational. That Hadoop brings really about a different paradigm, and oftentimes you will find that if you go into it thinking that it's a relational database, you will probably come up with the wrong design. We'll get into that in a little bit. Our operations team needed help. Literally, this was like swallowing an elephant, and so it was a bit too big for them. Hadoop is such a different tool. It will be unlike anything that you've really ever brought into the data center before. And so what we found here is that we needed to get help for the operations team. We needed to get more formal training, where the developers had been reading about Hadoop for a while and kind of understood the math behind some of the methodologies for it. The operations team was just kind of overwhelmed. They were used to dealing with a web server on a single server, and here we're suddenly dealing with a cluster of servers. The cost-benefit analysis, well, we kind of did something back in the envelope, but that's about as far as we got. It looked good. And the scenarios ended up not being done because basically we started our project that was going to use Hadoop. So before we finished the POC, there was enough momentum behind Hadoop that we ended up doing it without actually completing our POC to the level that we wanted to. I'm sure none of that ever happens at your companies. Okay, so about that thinking relational versus not. So here's a simple entity relationship diagram. Your data modelers are probably very familiar with this. In this case, we see that patients have multiple visits. Visits have doctors, and visits also have procedures. And this is a very common way of organizing your data in a relational system. In Hadoop, what we did was we said, well, let's turn this on its head. Because our system is so patient-centric, let's create a document for each patient. So JSON stands for JavaScript Object Notation. You may not know what that is, but if you think about XML, this is sort of XML light, without all the extra junk that XML carries with it. So this is a very, very simple way of describing data. And you can kind of even see it. Curly braces mean we're beginning an object, and there's pairs. A first name field, and the value is Fred. The last name, and the value is Flintstone. We have arrays with these square brackets which contain other objects and stuff like that. So anyways, it's just a way that we said, hey, because of the way Hadoop works and because of our particular problem set, it makes more sense for us to have one line of data. So again, Hadoop is a distributed file system, so imagine a huge file where each line in the file is this. Obviously without all the line breaks in here. And so each line would describe one patient. This had some incredible benefits for us because it meant that with one I/O, reading from the disk, I knew everything I needed to know about this patient. Versus in a relational system, I would probably do an I/O on the main table, I'd do an I/O on the visits, I'd do I/Os to get the doctors, I'd be doing I/Os to get all the procedures. And maybe if I'm lucky, I didn't need all of them. Whereas right here, I end up reading all of it all the time. But we found that this was a very game changer for us in terms of how we thought about our data. All right, so remember this reorg? That was sort of what we were talking about, is that, so what we went from, we're looking at inside the Hadoop cluster, we're dropping in our raw data that's coming out of, what's coming out of our transform process, is being dropped into Hadoop. We wrote a process that sort of created that JSON document, that converted all that data that was very disparate to be everything you needed to know about a patient, and created that patient file with all the patients in it, with all their data. We then have some additional statistical analyses that we add or augment the data with. So for instance, when we're dealing with a claims, we don't necessarily know exactly when you went in the hospital and when you came out, but you can kind of infer it from looking at the billing that occurred. So we have a module called admissions that basically will figure that out and then annotate the data accordingly to say, here's when they came into the hospital and here's when they came out. We have other things that does risk model scoring and things like that. Healthcare is a little bit like government. You kind of have acronym soup. So these were all the acronyms. But one of the things we also got out of this is because Hadoop storage is cheap, what it also came down to is that we could go with our builders, we could keep all this intermediate data. We could keep that raw data, we could keep the patient data, we could keep the patient plus data. And any of our systems that built their data marts could select any of those data sources to be the data source for their particular system. So not all of our systems are patient-centric. So at this point, the project had started and was working and was starting to move ahead. And in parallel, we were then trying to figure out which distribution did we want to select. 3 major distributions out there. They're all good. You will probably be successful, equally successful or unsuccessful with all 3. What we found is that Cloudera, to us, the big thing that they offered was they were the first mover, they were the most experienced, they're sort of the big boy in the market. They jumped on this bandwagon first and said, we are going to be the official distribution of Hadoop. Unfortunately, during our sales cycle, we did not get very good support from them. And so that concerned us. We didn't know whether they were just stretched or whether we were a small player, because we weren't talking about building a huge cluster. Not sure, but we just didn't quite get the support that we felt comfortable with. MapR probably had the best technology. So they've basically rewritten the core part, that distributed file system. They've rewritten that in C, whereas in normal Hadoop it's in Java. They rewrote it in C, so it is super fast. Hadoop does have a few critical nodes in the system. They rewrote that so that that wasn't there. They allowed advanced things like snapshotting, so that way you can sort of snapshot your storage system and know that if you wanted to, you could revert back to that particular state. So they were really impressive. But unfortunately, it did mean introducing a lot of proprietary software, because this was all custom written stuff and we would be counting on them to keep it up to snuff. Finally, Hortonworks was the third company we evaluated. They were basically just a pure open source solution. And our company was very comfortable with open source. They're probably the newest player out there, at least of these 3. But that was what we decided to go with. We decided to go with Hortonworks just because we felt that we liked the open source model. We felt that that had the longest legs, that would be best for the company in the long run. It also allowed us to potentially deploy solutions on customer sites and then have us be the support personnel and things like that. So it offered us a lot of good options. And frankly, because you're getting pure open source, all you're getting from them is a support contract. And if for some reason they didn't really support you well, it'd be pretty easy to go out and get a third party to fill in that gap. So we felt that also sort of gave us a good negotiating position when we worked with them. But we got excellent support from them. And when we did some of the training classes for our administrators, they came away saying it was great, which we found quite impressive, because a lot of our developers also went to that, and they said it was good. And usually developers kind of poo-poo training because they know it all already, and it's going too slow and things like that. But they came away saying that they learned a lot and they thought it was really worthwhile. Okay, so at this point, we've already got this project kicking off. Things are going wild, and everybody's hearing that we have Hadoop in the company, and so we need to calm the storm that's starting to rise, where Hadoop is not going to solve all our problems. So we started running around doing educational classes, both to our technical folks so that they understood Hadoop, understood its strengths and weaknesses, and to our executives, both so that they didn't architect solutions for us. Hey, we ought to do that with Hadoop. But also so that when they spoke to our customers, they could speak intelligently about it. And this is actually the summary slide of the things that they were supposed to learn, the executives were supposed to learn at the end of that process. Okay, there's some operational challenges that I alluded to earlier with Hadoop. For us, the operational challenges happen to be that we were going to be using Hadoop in a multi-tenant way. So we were going to have both multiple customers' data in Hadoop. We're also going to be having multiple applications that are going to be running their builders, their jobs, transforming data in Hadoop. And so what this meant was that we had to figure out a couple things. One is, how are we going to cost allocate Hadoop? Because our company is sort of used to everybody, I need a database. So I go out and buy my database. You know, and so this is the database for my application. And when you're talking about Hadoop, you really don't want to do that. Because you really want one cluster because, hey, when someone's not using their stuff, your jobs can make use of their additional processing power. So you really want to keep yourself down to ideally one production cluster and then probably a UAT and QA and all that other kind of stuff. But we also realized that, so there's a cost allocation, how are we going to charge each of our different groups? At this point, we're keeping it simple, and we're basically just going to charge based on disk usage. If we find that the actual processing power is what's in short supply, then we might try to transform that. But at this point, it's basically going to be how much data do you want to store in Hadoop? That's how we're going to cost allocate it out. We've also, interestingly, had to work out at what increments do we grow Hadoop. Because Hadoop tends to be pretty chatty over the network, you tend to want to isolate your Hadoop cluster from the rest of your systems. And so you typically will buy racks of Hadoop machines. Now, they're not quite as expensive as you think because you're generally getting servers that are almost near the end of the life. You know, it's like, this is the last year Dell is going to be selling these. Those are the kind of servers you actually want to buy because you're getting the most bang for your buck. Job coordination. So again, you know, everybody's used to kicking off their jobs at midnight. Well, that isn't actually going to be able to happen when you've got a whole bunch of people on the cluster. And so you're going to need to work through some of those job coordination issues. Growing the cluster, so adding servers is generally rather straightforward. Again, what's your increment? So we're looking at maybe doing half rack or whole rack increments. So we'll just buy a bunch once we hit our certain threshold and keep growing our cluster because we know the demand's going to be there. We know that our needs are going to keep growing as we go along. Upgrading software becomes a real problem. Because everybody's sharing the same thing, when you upgrade from Hadoop 1 to Hadoop 2, you got a lot of coordination that needs to happen. Because not everything is backwards compatible, and you need to test it out and make sure it's working. And so this is a level of coordination that we as a company hadn't had to do in the past because everybody sort of had their own stuff. And so this is going to require some additional work from us. Management, obviously we have SLAs, who approves who gets on the cluster, how does that work? What's the uptime requirements? Are we going to have 2 Hadoop clusters, 1 Hadoop cluster? Disaster recovery is a big one. Because if you're talking about a cluster of Hadoop that can be holding petabytes of data, the question becomes one of what do you do when someone does the delete star dot star and goes, whoops, how do you get that data back? And backing up the cluster itself doesn't really seem to be an option because you have potentially hundreds of machines that are really working in sync. And so to back up one at one time and another at another time doesn't mean that you're going to get a good restore. So it's a big issue that you need to be working out as you're moving forward. Finally, for us, because we deal with so much PHI data, security is a big one too. And so who's going to have access to the data? How are they going to have access to the data? How do we lock it down? How are we going to handle encryption? Those are kind of other issues that we have to deal with. So future. So where are we going to go in the future with our Hadoop? One is we're looking at getting more analytics into our Hadoop cluster. So up until this point, we've been talking about using Hadoop as more of a heavy lifting machine, not so much as an analytic engine. And so this would be a matter of bringing in additional analytics into the cluster. R is a statistical language that's an open source statistical language. It's becoming very popular. And there's a lot of integration work that's being done with R and Hadoop. because of its open source model and the fact that it's free. You can put sort of like a copy of R on every single node in your cluster and not be paying through the nose for that. In other areas, for our data mart, near real-time technology. So there's some technologies that are out there for Hadoop that are looking to bring that real-time or near real-time response time to Hadoop. So there's a couple open source projects. One is called TES, which is really just about speeding up that Hadoop scheduler so that the normal jobs that you do, they can happen much quicker. There's another one called Apache Drill, which is based on some technology from Google, as Hadoop is actually based on technology from Google. They're looking to there's an open source project to bring that into place, and Cloudera is even working on a technology called Impala, which is going to do something very similar. So there's a real desire to bring big data analytics up into that near real-time kind of response time mode. So we are keeping a careful eye on that. Again, going back to that earlier problem that we have, which is counting patients. And what it means is that a lot of our data marts actually have all the patients in them, and so it's not really summarized real well. Because a lot of times the analysts are doing things like, okay, I want to find diabetics who had aspirin, 4 days before they had an XYZ procedure, and it's rather complicated and rather detailed, not the kind of thing that you can summarize real well and just slice and dice with. And so we see these technologies as being real game changers for us in the way that we're able to provide real-time analytics to our customers. Finally, there's the element of going back and addressing this transform and load process. From what I can tell in reading about the industry, most people seem to use Hadoop now to just sort of dump their raw data into Hadoop, and they do everything inside of Hadoop. And so they'll put that raw data in there, their ETL jobs, their data cleansing jobs, all that kind of stuff will be written in Hadoop to run in Hadoop. And also to sort of emphasize that, I know that Informatica has done a lot of work to get their software to run their jobs, supposedly unchanged, within Hadoop. And so the ETL vendors are even seeing that a lot of the ETL processes that take so long can be sped up by attacking it with many processors.
Can I ask one question?
Yes.
In one of the earlier slides, when you took an initial study, like where Hadoop would fit in,
Yes.
there was some criteria that went in for you to reject. Hadoop is not a good fit for transform and loads.
Right.
What was that, and now in the future,
Okay.
going back to Hadoop, can you?
Right. So he was saying is that earlier when I showed, when you had the little Hadoops and there were little Hadoop elephants and there were red X's and there were, green check marks, and we had rejected it here at this transform and load. And so the criteria, why did we reject it? Well, our biggest problem was a labor problem, and it doesn't really help in that. But the other element was we have invested so much time and effort into our ETL processes that the payback of moving them into Hadoop just wasn't there. So the increase in performance, we kind of looked at it and we said, well, we're pretty happy with the performance that we're getting. Could it be better? Yeah, but is cutting it in half critical for us? And we didn't think it was. So we looked at it at a high level, and that were some of the things. So it was primarily a labor problem there. It would speed things up, but we didn't think it was going to speed things up significantly. And frankly, it was going to be a hard sell because we've invested so much in our existing ETL structure that nobody really wanted to go back to management and said, remember all that ETL work we did? Well, we want to do it again. So there's a little bit of a political thing to that. Okay, so the lessons. So the lessons are be prepared to think different. Hadoop is a very different technology than you probably worked with before. So be prepared to think different, to deal with the fact that this is a file system, it's not a database, to deal with the fact that the algorithms like to do this map reduce thing rather than sort of normal one row at a time, I'm going to look at it kind of approach. And so it's going to require a team that's rather open to looking at those new technologies. Second is sort of, that kind of goes with it, is expect to grow this organically. There's a you know, as we learned from healthcare.gov, that you can throw $500 million at something and it doesn't necessarily mean that you're going to get it done in time. There's a certain amount of time that it just takes the team to get experience. You can send them to training to kind of accelerate that, but there's just a certain natural amount of time that they're going to need to learn how to work with the technology, to know what it's good at, to know why it isn't working. And if you start pushing too much onto your Hadoop project, you're probably going to push it to fail. So be prepared for a certain amount of organic time that it just needs to bake a while. Finally, I'd say focus on your best people. Get your best people on this. This is a technology that will probably be with your company now and forever. And you really want your best people setting the standards, setting the principles, how you're going to use it, what you're going to use it for. So you really want to try to get your best people on this project. Your best people are also the people that are more likely to be the ones that are able to think different. They're also going to be the ones that are going to be able to sort of look at this whole kaleidoscope of technologies and be able to say, yeah, this one sounds interesting. No, I don't think this one's going to have any effect for us. So the three main lessons that I'd have you take away is think different, look for organic growth, and get your best people on the project. So at this point, do I have any questions?
You talked about the security. Could you talk a little bit as to how did you implement that using Hadoop?
It's in process. So one of the problems we had was we presented a plan to our security team and we said, here's how we're going to lock it down. We decided that we were going to we looked at some best practices on Hortonworks' site. We did some other research. Most of them talk about having gateway machines. So your developers don't, or technical team doesn't actually get access into the Hadoop cluster. They go to these gateway machines, and then from there they launch jobs, query the data, do things like that. And so you kind of create a little walled garden around your Hadoop cluster. So we presented that plan. We also did some other things, Unix privileges and things like that around users. We have encrypted file systems in place. We're looking at application level encryption, the whole gamut. You know, we gotta do it to the nines. So here was an interesting rub, is that we then presented this plan to our security team and we said, oh, here is our plan for making Hadoop secure. So we go through all the plan, we explain everything, and they kind of got to the end and they kind of went, what's Hadoop? Obviously, they hadn't come to any of our company education. But again, we're dealing with something that was so completely different from anything. They were used to locking down a server, and that was enough. Dealing with firewall rules, and that was enough. And suddenly, we were at this point where, no, it's everywhere. It's this huge thing. There isn't one, you can't, there's lots. And they just had a hard time understanding it. So we're in the process now of educating them, helping them understand it, understand how the security works, getting them talking with Hortonworks security experts to kind of bring that all into place. But no, it hasn't been easy. Yes?
You included analytics on your future slide.
Yes.
And mentioned R.
Yes.
Do you have any particular analytic needs that probably are not being met by R? Perhaps time series analyses and so on, where you're looking for better analytics?
Yeah, there's also, our analytics team tends to use a lot of SAS. And so that's and so R is just the open source version. SAS has some Hadoop integration. And again, we haven't really addressed it in detail. Our analytics team has come and said, hey, we heard we have with Hadoop. We have some stuff that we think we want to do there. That discussion is ongoing. So we haven't really done the analysis to find out where the gaps are between R and SAS, whether we want to pay for SAS over our cluster, things like that. Certainly almost all tools now that your ETL tools, your statistical tools, almost all of them have Hadoop connectors, which basically mean they know how to suck files out of that cluster. Okay. Are we done?
Yes, but that's fine, go ahead, take care.
All right, I think one,
You mentioned that, your closing comment, think different.
yeah,
And you had a side comment that was, this is a file system, not a database.
Yeah.
And yet, most people are looking at this as potentially a replacement for a data warehouse, or
Right.
certainly as a complement to a data warehouse.
yeah,
But they're two different structures. Can you
yes,
comment further on that?
yeah. Yeah, so the relational data model really implies that you're trying to do third normal form stuff. You're dealing with star schemas. We've understood how to optimize things to get stuff out of Hadoop out of a relational database quickly, how to structure it well for our BI queries and things like that. Hadoop being a file system, that in itself is often, because I can't tell you how many times I've had people that talk about Hadoop as if it was a database. Well, where's my XYZ table? And I kind of go, well, there really isn't an XYZ table. And then they're kind of like, I don't understand. How do I do joins? Well, you can kind of do joins, but joins are pretty expensive. Because you have to sort the whole file and then merge it together, and they're kind of like, what are you talking about? So, even though it's simple, it's a file system, it's distributed nature, and stuff makes it much more difficult for people just to get their heads around, especially if, I come from a company where, Oracle is everybody's middle name. And so the idea of, well, how would you do that? That's impossible. There's no Oracle in it. It's a little bit like Linus with his blanket, Don't take that from me. So there's a cultural component. I think if you're able to get beyond the fact that it's there, I think it becomes easier, but oftentimes we have this paradigm of how things work, and it's very difficult for that to get out of people's heads. So I'm not sure if that got your question. You can come up and talk to me a little bit more afterwards. Okay, thank you very much. I appreciate your coming.